Hello, Namaste. Welcome to Swami Vivekananda GS. If you are preparing for competitive exams like SSC, RRB, TGPolice, you are at the right place. Today we will be discussing the part 3 of optics. And in this part 3, we will be discussing about refraction. What is refraction? With the help of definition, we will be learning what is refraction. When light moves from one medium to another medium due to speed changes. Because of change in speed, the light bends. These bending of light is called refraction. That means if this is a plane, this is medium 1, this is medium 2, when an incidence ray falls on a mirror and it will move towards the medium 2. In before classes, in reflection, we have learned that the bouncing back of light ray when striking to a reflector is known as reflection, whereas here it travels from one medium to another medium, that is rarer medium, rarer medium to denser medium, or denser medium to rarer medium. Then the bending of light takes place. The bending of light is known as refraction. As we know, this is incidence ray, this is refracted ray. When light travels from one medium to another medium due to changing in speed, that means here due to speed changes, that means in rarer medium the speed of light is high. In denser medium, the speed of light is low. When high speed light moves from rarer medium to denser medium, its speed is decreasing. Due to speed decreases, the light will bend towards the normal, and the angle between refraction ray, refraction ray and normal is known as refraction angle, that is R, reflection angle. This angle is known as incidence angle. That means when light moves from one medium to another medium due to speed changes, from one medium to another medium, that is rarer to denser, speed changes. Because of change in speed, the light bends. The bending of light is known as refraction. Copy this. We can include the examples of rarer medium. If we take rarer medium examples, vacuum and air. For denser medium, examples will be solid and liquid. What is speed of light? In one line, we will be learning what is speed of light. Speed of light. The distance traveled by a light in 1 second is known as speed of light. That is, speed of light is here I mentioned as SOA. As we know, in vacuum, speed of light is 299,910 kilometer per second. This is the exact value given by the scientist called Albert Michelson in 1879. He is the scientist from USA who gave the value of vacuum of light in vacuum. What is vacuum? Some students don't know what is vacuum. Empty space. For example, we are living in a room where oxygen and other gases are present in this. When we eliminate that gases also, that is no air, no gases, no other matter, any matter we can take. Eliminate all these. Then the medium is called vacuum. In vacuum, the speed of the light is 299,910. That is approximately 3 into 10 power 8 meters per second, or else 3 into 10 power 5 kilometer per second, or else 3 lakh kilometer per second. In exam, he will be asking in the units, he will be just changing the units. In meters per second, the value is 3 into 10 power 8 meters per second. In kilometers, 10 power 3 into 10 power 5 kilometer per second. If we give in a lakhs, 3 lakhs kilometer per second. From this data, we know that for 1 second, the light is traveling at 3 into 10 power 3 lakh kilometer per second. If you want to know the distance between the earth and the sun, then as we know, when the light is emitted from the sun to reach the earth, it will take 8 minutes 20 seconds. If you convert these 8 minutes 20 seconds into seconds, it will be 500 seconds. For 1 second, the light will be traveling at 3 lakh kilometer per second. If you want to know the distance between the earth and the sun, if you cross multiply 500 into 3 lakh kilometer per second divided by 1, then it will be 3 5 ja 15, 0 lakh kilometer per second. It is equals to 15 crore kilometer per second. For 15 crore kilometer, in terms of sun's distance, when we are calculating the distance between the sun and the earth, will be calculating a unit called astronomical unit. Astronomical unit. One AU, that is, it is denoted with AU. One AU is equals to 15 CR kilometer per second. If the examiner will ask the distance between the sun and earth, then he will be giving in kilometers or in crores, in crores or in AU. For AU, it will be 1 AU, the distance between earth and sun. If you want to know in terms of crore, that is 15 crore kilometer per second. This is an important statements you have to remember for your competitive exams. Copy this. Now we will be learning absolute refractive index. What is absolute refractive index? Absolute refractive index. It will be denoted with N or mu. N or mu. That is, the definition is the ratio of ratio of speed of light in vacuum to the ratio of light in that medium. That means the ratio of light of vacuum, the speed of the light in vacuum, that is 3 into 10 power 8, and the medium of which you have to find out. For example, n is equals to C by V. N is equals to C by V, where n is equals to absolute refractive index. C is speed of light in vacuum, whereas V is speed of light in that medium. That means the medium, the respective of medium in which we have to find out in whether if you take glass, air, liquid or diamond, etc., etc. Copy this. Now I will be writing some important refractive index values, that is n is 1 for vacuum. The refractive index for vacuum is 1. For air it will be 1.003. For ice it will be 1.31. For water it will be 4 by 3 or else 1.33. For kerosene 1.41. For glass, glycerin and benzene, the value is 1.5. For rock salt, it is 1.54. For diamond, 2.14. These are the values very important for competitive exams. You have to remember the values. If he gives the, if he wants to make you to solve, if he gave the velocity of the, if he gave the refractive index of kerosene, for example, then you can find out the velocity of kerosene while light flowing from the medium of kerosene. If he is not giving the velocity of refractive index, then you have to find out C by V. That means he will be giving the velocity of the light traveling to kerosene. Then C by V. For example, he will be giving 3 into 10 power 8 meters per second. If we think, if the value given by the examiner is of light traveling to kerosene medium, that is 2 into 10 power 8 meters per second, then 10 power 8 cancels. 3 by 2 is the refractive index of kerosene, or else yes, that is 1.5. That is, we got the refractive index of glass, glycerin and benzene, glycerin and benzene glass. This is the example how the examiner will ask to you in the examination. Now I have taken a PYQ of RRB in which the examiner have asked, arrange the refractive index of the given mediums in ascending order. I will be not rubbing this so that you can answer very quickly by seeing this. The question is, following options represents the correct ascending order of refractive index of certain substances. Option A, rock salt, benzene, kerosene and ice. The second option is kerosene, ice, benzene and rock salt. Third option is rock salt, ice, benzene and kerosene. Fourth option is ice, kerosene, benzene and rock salt. The correct option is ascending order. You have to set in ascending order. If we take the rock salt value is 1.54. 1 point, I will be writing here 1.54, 1.5 glass. Kerosene is 1.41. For ice is 1.31. This doesn't satisfy because it is in descending order, not ascending order. So it is wrong. Second one is kerosene. Kerosene is 1.41. Ice is 1.31. Benzene is 1.5. Rock salt is 1.54. It is also not satisfy the given statement. The third one is rock salt. Rock salt is 1.54. Ice is 1.31. Benzene is 1.5. Kerosene is 1.41. It is also not satisfied. The last one is ice. Ice is 1.31. Kerosene is 1.41. Benzene 1.5. Rock salt is 1.54. The last option satisfy the given statement. So option D is the correct answer. The main intention of mine is to learn in a very easy manner. If you are learning the concept right now and if you are solving one question related to this concept, it will be easy to you that you can recall after a long time. That is my intention. Please copy this. Now we will be solving some questions that is related to refractive index. One question from refractive index, then we will be moving ahead with another topic. As we know that the formula for refractive index is N or mu is equals to C by V. The question is asking is he has given C as 3 into 10 power 8 meter per second, that is vacuum's speed of light, and he has given N as 3 by 2, that is refractive index he has given. Now you have to solve the velocity of the related to this. If you know this is 3 by 2, the refractive index of value 3 by 2 relates with, here we can see it relates to glass. So you will be writing mu is equals to mu g is equals to C by Vg. Here we will be transferring Vg here and C by mu g equals, C is 3 into 10 power 8 and mu g the value is 3 by 2. If you cancel 3 by 3, it will be goes upward and it will become meters per second. The value we got is 2 into 10 power 8 meters per second. These type of questions will be asking in exam. If you have a strong base on the concept, you can solve in very few seconds. If you don't have, then you will be lagging with these problems. So my suggestion is, if you have a strong base in the subject, you can answer any type of question. You will be seeing the question as very easy. Whereas the other people who doesn't have the concept stronger, they will be lacking with the time and they will so much lacking of getting the selection in the government services. Now we will be learning. I want to add one point. Sorry, I have missed one. It is refractive index. It is unitless quantity because n is equals to c by v. The units for c is meters per second. Here meters per second. When both will be cancelled, n has no units. So it is known as unitless quantity. Now we will be learning how light behaves when it moves from rarer medium to denser medium to rarer medium. When the light travels through the normal, how it behaves. When what is the situation when light will be acting as when it strikes to a transparent glass, that it doesn't bend, it will be moving in a same direction when it strikes the transparent glass. Now case 1, when light moves from rarer medium to denser medium. If we take, this is an example, this is a plane, this is medium 1, this is medium 2. A incidence ray travels from here and striking the mirror, and it will, in this case, it will be moves closer to normal. That is, when an incidence ray strikes the mirror and it will move, when incidence ray travels from rarer medium to denser medium, this is denser medium. Previously we have learned, that means in the starting of this lecture we have learned that in denser medium the light will travel slowly, whereas in rarer medium it will travel very fast. When the speed decreases, due to which the light will bend, that is the same thing which happens here. The light will bends, but it bends towards the normal. That is, this is known as refracted ray, refracted angle. In the previous lecture we have learned, in the reflection we have learned that the angle made between normal and reflection ray is known as reflection angle, that is denoted with R. The angle made between normal and incidence ray, it is known as incidence angle I. That means in when light moves from rarer medium to denser medium, note the reflected ray will comes towards the normal. Will comes towards the normal. That is, this is rarer medium, this is denser medium. And the second point is the angle made by incidence ray is greater than reflected ray. RR means reflected ray. That is, small I is greater than R. The examiner will ask these type of statements directly. Please copy this. After this, we will be discussing the second case, when light moves from denser to rarer medium. Here you can add, in rarer, speed of light is fast or high. Here speed is slow or low. That's why it will be bends towards the normal. Now we will be discussing when light moves from denser medium to rarer medium. Case 2. This is incidence ray. This is the plane. This is normal. Here normal. This is denser medium. Light moves slower. This is rarer medium. Light moves faster. When these incidence ray move from denser medium to rarer medium, here it will be moving away from the normal, because in denser medium the speed of the light is very low. When it moves from denser medium to rarer medium, the speed of the light will be increases, because it is a vacuum, it is air, there is no obstruction of any particles, because in vacuum there is no presence of matter like air, uh, any gases, any solid, nothing is there, it is an empty space, that is vacuum. So the light will flow in very fast, so it will move away from normal. So the angle made between normal and reflected ray is known as R, reflection angle. It is known as I. So you can write here the reflected ray will move away from normal, refracted ray. Sorry. Refracted ray will move away from the normal. And another point is the angle made by incidence angle is less than refracted angle. That is, I is less than R. The 2 points is very important. Now we will be discussing the third case. It is very important case because the examiner is having love with this case because he will be confusing the students. How we will be knowing? When a light moves along the normal from rarer medium to denser medium, denser medium, rarer medium to denser medium. If this is a plane, this is normal. As we know, this is rarer medium, this is denser medium. Light is moving along the normal. So the refracted ray will never changes its direction. It will move same as how it is moving in rarer medium. That means rarer medium or to denser medium. That means the light ray traveling from along the normal will never change its direction. Most of the students will be in the hurry when in examination. The most of the students in hurry, so they will be learning reading only this statement. When the light ray moving from rarer to denser medium, they will be just taking it is towards the normal. But the second sentence he will be writing, when light moves along the normal, then the answer will be completely opposite. That is, it doesn't change its direction, it doesn't refract, it will be traveling through the normal. So the answer is no change in direction. That means it doesn't refract, it only moves from it moves along the normal. Please copy this. No change in angle. Now, sorry, this is case 3. Please write as case 3. Now, we will be learning if we use the material or a substance of same absolute refractive index, that is same refractive index material, if we use in rarer and denser medium, what will be happening? If we take glass, the glass refractive index is 3/2 or 1.5. Refractive index of glass is 3/2 or 1.5 of glass. Refractive index of glass is 3/2 or 1.5. When a incidence ray travels from rarer medium to denser medium, it doesn't change its direction. It will behave when a light ray traveling from a transparent medium, a transparent substance. When light travels from transparent substance, it doesn't change its direction. Like that, when we use same medium, that is same substance, here refractive index is 1.5, here refractive index is 1.5. That is, there is no change in refractive index. So the light will behave like it never diverts its direction. Refracted ray. That means, note, when same substances of having refractive index same, then the result will be no change in direction or deviation of a light ray. When it will be obeys this type of law, when the refractive index, when we are using the same refractive index in the rarer medium and the denser medium, when the light will, when the incident light travels from one medium to another medium, then the light will behave as same. It never changes its directions or diverts. This is case 4. That is refractive index. Here we are using glass, here you are using benzene, because the benzene and the glass both having the refractive index of 1.5. In rarer method we are using glass, in denser medium we are using benzene. Previously we have discussed that the benzene, glycerin and glass, three of having the same refractive index, that is 1.5. So it never diverts or never changes its direction. Please rewrite it is, when different substances having same refractive index same, then the result will be no change in direction or deviation. Different substances, different substances of same refractive index. Benzene, both are having same refractive index of 1.5. Here glass, here benzene. Now we will be solving one PYQ and we will be wind upping this class. Question is, when a ray of light travels from a denser medium to rarer medium, then speed of light. Options are: it speeds up and bends away from normal. B option is it speeds up and bends towards normal. Option C, it slows down and bends away from normal. Option D, it slows down and bends towards the normal. Towards normal. We have learned when a light moves from rarer medium to denser medium, it will bending towards the normal. Here he told that the light is moving from denser to rarer. Here denser medium to rarer medium. That means this is denser medium, this is rarer medium. That means in denser medium the speed of the light is very low. In rarer medium the speed of the light is very high. Then when it passes, that means when it travels from denser medium to rarer medium, the speed of the light is high and the speed also increases. That's why it moves away and speed up. Let's see where is the option. It speeds up and bends away from the normal. This is the correct answer. We will be checking. It speeds up, bends towards the normal, towards, not away from the normal. It slows down. This is wrong. It slows down. This is wrong. This is the type of technique you have to learn. We have to eliminate the options. If you have a strong base in the concept, then you can easily eliminate the options from the given question. Now, today we will be stopping this session and we will be discussing the remaining topics in the next video. Thank you for watching this video. As you know, I will be sharing one quote from Swami Vivekananda in my every video. That is from which I have inspired and I have kept the name of his for my channel. That is, arise, awake, stop not till you reach your goal. If you like my video, please share with your friends and family members. Thank you.
With experienced faculty, small batches, regular tests and dedicated doubt clearing sessions, we help every student achieve their best. Limited seats available and shape your bright future.